Okay, so in this example, we will show an application of classification, and this problem is about predicting whether a person in the US uh, will pay uh, a high cost for will have a high charge for his health insurance. So we have a number of people, of which we have the age, sex, body mass index, that is a number that reflects how thin or fat you are, number of children, whether they smoke or not, the region in the US, so southwest, southeast, northwest, etc., and the annual charges for the health insurance. So we will divide the health insurance charges into 4 quarters, and we want to predict whether a person is in the highest quarter. So as always, we compare the variables that have been read as objects into categories, and now we will explore the data. So we see what is the average mean, what is the average age, what is the average body mass index, number of children, and average charges. And but we see that the charges, for instance, they have a huge range from 1,000 to 63,000, with a mean of 13,000. Okay, so here we have the charges, a representation of the charges. So we will take the upper quarter and we will try to predict whether this person belongs to that quarter. We can also, for instance, make plots of the charges separated by sex, and visually at least it doesn't seem that there is any difference between the two distributions. And uh, we see that half of the people are male, the other half are females. Most of the people are not smokers, while a few of them, not a few, but 20% of them are smokers. And then in terms of regions, more or less all the regions are equally represented. And we may check whether there is a relationship between smoking and sex. So for instance, here we have a cross table, and in this cross table we have that 500 females uh, do not smoke while 100 smoke, and 500 males do not smoke and 160 do smoke. So there is a relationship between these two variables that uh, and the p-value associated to the null hypothesis that there is no association between the two variables is very small. So there is a relationship between being male or female and smoking, yes or no, in the direction that males tend to smoke more. Okay, now we will construct this upper quarter variable. So this is the way to do it, and now we will see whether this person is in the upper quarter, this person is not, this person is not, but this person is, and so on. Okay, so we will check whether there are relationships between each one of the variables and being in the upper quarter or not. So there is a relationship between sex and upper quarter, smoker and upper quarter, and the region and upper quarter. So it seems that all these variables are related to being into the upper quarter. And to represent that, we can show, for instance, or to check the other variables. We have the age, so we see that it doesn't seem to be or that there is a difference between the ages not being in the upper quarter and being in the upper quarter. So the distribution of ages seem to be more or less the same, and the same for the body mass index. It seems that these people tend to be a little bit thinner, but not so much. We will see later. And the other one is number of children. So again, it doesn't seem that there is a difference in the number of children. So the classification tree, we will use all these variables as predictors, and we want to predict this one. And we check that we have not done any mistakes. We show the 5 first rows. And okay, so a big mistake is if you put the upper quarter as one of the predictors, because otherwise, if you do so, the classification is trivial. And okay, so we have here the top of the predictors, the top of the predicted values that we want to predict. We expand the X predictors into this one-hot encoding, because the classification tool that we will use cannot handle categorical variables. It can only do it with one-hot encoding. And then we have constructed here, it is the we have constructed, what is it, so here we have defined the classification tree. So it is just a class, and then here we are fitting it, and then here we are trying to predict, to make to see whether we are doing well or not. And it seems that we are doing extremely well, 99.9% of accuracy. And we can look at the tree. So for instance here, if you don't smoke and your body mass index is smaller than 22 and your age is smaller than 28, then and your region is southwest, then you will not be in the upper quarter. But if your age, for instance, if your age is smaller than 28, but you are in the southwest with an age larger than 20 years old, then you will be in the upper quarter as well. So we see that this is a very long tree. That is why it classifies so well. So probably there is some kind of overfitting there. And the current depth of the tree is 17. So at every one of these decisions, we have at every one of these decisions, we have a level of the tree. So first question is the first level, second question is the second level. So to classify these people, we have made 17 questions. So that is why it classifies so well. It has divided the data into so many small pieces that it is very easy to classify them well. And here we have the classification accuracy for different depths. And we see that in this particular case, Gini is much better than entropy, and but even very simple trees, they have a good classification power. So they make a mistake in only 5-6% of the data. So that is the complement of this. Okay, so let's look at classification with a maximum depth of 2, and the classification error or the accuracy is pretty high. It is not 99%, but probably this 99 is an overfitting. So what are the two most important questions? So the first important question is whether you smoke or not. So if you don't smoke, then you go this way, and if you don't smoke, you see that all of them are false. So meaning you don't belong to the upper quarter. Here we have the composition of those data. So we have in total 1,300 people. Out of these 1,300 people, 1,000 has the low value, so they are in the lower quarters, and 300 are in the upper quarters. If you smoke, we see that it is much more homogeneous, so the entropy has dropped quite a lot, and most of the people will be in the upper quarter. Actually, this interpretation class equal false is kind of arbitrary in this representation, but we see that most of the people are in the upper quarter if you smoke, and if you don't smoke, most of the people is in the lower quarters, and only a few are in the upper quarters, and still we can even not separate, we are not able to separate them, so we cannot predict anyone here, that with just this question we cannot predict those in the upper quarter. So yeah, so the main question is whether you smoke or not. So the second level questions, they don't really discriminate. You see, true, true, false, false. So there is no discrimination. And this is the confusion matrix. So the confusion matrix is a matrix in which you count how many people have a given true label and a given predicted label. So if they are not in the upper quarter, you would like to predict that they are not in the upper quarter, and if they are, you would like to predict that they are. So these two are correct assignments, while these two are incorrect assignments. And we see that it is much easier to predict whether someone will not be in the upper quarter than whether someone will be in the upper quarter. So this number of errors is larger than this number of errors. And we can construct a very, very simple classifier with just a depth of 1, and we see that the question is whether you smoke or not, and the classification error, yeah, the accuracy is 92.6. so this is a very accurate within quotes classifier with only one question. So smoking is really bad if you have to pay a health insurance in the US. So this is the example that we have today, and then we will discuss about the theory.